Welcome once again to the Mojo Math and Science. Today, we'll see indices, we'll look at the product law, and we'll also see fractional law. To the end of the class, we'll look at these two questions. We'll use these two questions to understand product law and fractional law. To ensure you continue to receive our content, please do not forget to subscribe and hit the notification bell on viewing us on Facebook. Please do not forget to follow, like, and share this lesson with a friend. If you have an equation like this, 3 raised to power 5 or raised to power 3. The easiest way you can express this is to think of it as 3 raised to power 5 times 3 raised to power 5 times 3 raised to power 5. Now, we'll be saying that is something as in 3 times 3 times 3 times 3 times 3. This is 5. You repeat it again, times 3 times 3 times 3 times 3 times 3. Now let me bring the third one here. Then the third one is 3 times 3 times 3 times 3 times 3. Now if you count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we're saying that this expression is the same thing as writing 3 raised to power 15. Now, uniquely, if you look at this, you see that my 3 raised to power 5 or raised to power 3 is the same thing as writing 3 raised to power 5 times 3, which is equal to 3 raised to power 15. That means we can conclude that if I have my x raised to power a or now raised to power b, is same thing as writing x raised to power a times b. This is the product law. That's a product law. Now, from here, let's see how to treat exponentials. When we talk of fractional indices, we're actually referring to roots. Take for example, if I have, it's the same thing as writing y raised to power half. If I have the cube root of y, it's the same thing as writing y raised to power 1 over 3. Now, if I have this, if I have the root of 49, look at it this way. That's the same thing as writing 49 raised to power half. So that 49 is something as 7 times 7. That's 7 times 7 all raised to power half. That's writing 7 raised to power 2 all raised to power what? Half. 2 here is 1, 2 here is 1. So this becomes what? 7. Let's just quickly take another closed example. If I have this 0.125 all raised to power 1 over 3. This is something as writing 125 over 1000 because you have your point here. Now I'm going to now raise it to power what? 1 over 3. Now, you remember that your 125 is the same thing as 5 times 5 times 5. And my 1000 is something as 10 times 10 times 10. All raised to power, remember, is raised to power 1 over 3. So that if this is raised to power 1 over 3, I am saying that this is something as 5 times 5, 5 times 5 times 5, that's something as 5 raised to power 3. All over 10 times 10 times 10, that's the same thing as writing 10 raised to power 3. Remember that everything here now is raised to power 1 over 3. So I've said this is 5 over 10, everything raised to power 3, now raised to power what? 1 over 3. 3 here is 1, 3 here is 1. So we now have 5 all over 10. Let's take the last two examples and we'll be done. Now, our first example says if 5 raised to power 2 all raised to power x minus 1. You see that this is a clear example of product law. Raised to power 2. My 5 raised to power 2, I can write this out as from product law. This is 2 times x. That becomes 2x minus 2 times 1, that's 2, times 5 raised to power x plus 1 is equals to 0.04. I can interpret that as 4 over 100 because I have point here, I have 0 and I have 4. Converting that decimal to fraction, it becomes 4 over 100. Now, from here, my 5 raised to power 2x minus 2 times 5 raised to power 2x plus 1, from my addition law, you know that this is 5 raised to power 2x minus 2. Since the base are the same, then I can add the powers. Plus x plus 1 is equals to 4 over 100. That's the same thing as writing 2 over 10 all raised to power what? 2. 2 over 10 all raised to power 2. Then I can break this down to 2 here is 1, 2 here is what? Is 5. That's the same thing as writing 1 over 5 all raised to power 2. If this is 1 over 5 all raised to power 2, all raised to power 2, then I can now come down to say this is 5 raised to power 2x. This is 2x plus x. We'll pick like terms. That becomes 3x minus 2 plus 1. That's minus 1. Is equals to, now, your 1 over 5. I can write this. 1 over 5 is the same thing as 5 raised to power minus 1. All brackets raised to power 2. So this is the same thing as writing 5 minus 1 here times 2 from our product law becomes minus 2. So the base are the same. 5 raised to power 3x minus 1 is equal to 5 raised to power minus 2. So I can equate the powers. You can equate the powers. It becomes equating the powers, it becomes 3x minus 1 is equals to minus 2. 3x is equals to minus 2 plus 1, which is equals to minus 1. X is equals to minus 1 over 3. So the value of x is minus 1 over 3. Let's see our second question. For question 2, we have that 3 times 9 plus 1. Now, if you look at the base, here, the first thing here, we have 3, we have 9, and we have 27. They are all in the powers of 3. So, this is 3 times 9. 9 is 3 raised to power 2, all raised to power 1 plus y is equals to 3 raised to power 3. 27 is 3 raised to power 3, all raised to power what? Minus y. So that this is 3 times 3, 2 times 1, that's 2, plus 2y is equals to 3, all raised to power minus 3y. We have my 3, it becomes 3. 3 is something as 3 raised to power 1. This 3 raised to power 1 plus, because 3 times 3x, 3 raised to power 2, the multiplication becomes the addition rule. We use our addition rule. It becomes 3 plus 2 plus 2y is equals to 3 minus 3y. So that's 1 plus 2, that's 3, plus 2y is equals to 3 minus 3y. So that the bases are equal, then the powers, you can equate them. 3 plus 2y is equals to minus 3y. That means 3 is equals to minus 3y minus 2y. 3 is equals to minus 5y. Divide both sides by minus 5. Divide this by minus 5. That means my minus 3 over 5 is equals to y. Thank you for staying with us. If this is the first time you come in contact with our channel, do not forget to hit the subscribe button. Thank you. Do have a lovely time.